Today we're going to start trigonometry, and we'll spend the next couple of months studying this branch of math called trigonometry. What trigonometry is you can split up this word trigonometry. The first three letters, T-R-I, that means triangle. And then the last part of this word trigonometry, this metry, this means a measurement. So what we're really doing is we're measuring triangles when we're studying trigonometry. And what kind of triangles we're going to measure today are right triangles. Right triangles, using trigonometry, you can use something called SohCohToa. You might remember this from a previous math class. You might remember the story of SohCohToa. SohCohToa was an old Indian maid, and she was walking through the woods one day on her way to the stream. And on her way to the stream, she bumped her foot really hard against a stump, and her foot hurt so bad she had to go down to the stream and Sohcahtoa. That's just a joke. Anyways, this is the little phrase we're going to use to measure our right triangles. So today we're going to talk about 6 trigonometric functions. Now these functions are really fractions in this top part, or this first half of this page 1. We're only going to talk about page 1 today. But these functions, like I said, we're going to talk about them as fractions. The first fraction we're going to talk about is the sine. And the sine is just a measurement of a right triangle. And if you draw a right triangle, I'll draw one over here. You can draw a right triangle here. Right triangles have to have a little box in the corner indicating that it's a right triangle. And we often refer to a specific angle with a little arc in there. So let's refer to this angle right here in the left-hand corner. That's going to be our angle. From this angle, we can go straight across from it, and we're going to get to the opposite side. From the right angle in the triangle, we can go straight across from the right angle, and that's called the hypotenuse. Hypotenuse. Hopefully these words are not unfamiliar to you. And then the other side of this triangle is the side that's right next to or right beside this angle. It's called the adjacent side. Triangles have 6 parts. They have 3 sides, and the 3 sides, according to one of the angles, are the opposite, the adjacent, and the hypotenuse. And triangles also have 3 angles. So 3 angles, 3 sides make up 6 parts of a right triangle, or 6 parts of any triangle for that matter. When we talk about the sine of a triangle, or sine of an angle in a triangle, we're talking about a fraction. And the fraction that we're talking about is when you take the opposite side and divide it by the hypotenuse. We usually know how long these sides are, or we're given the length of at least 2 of the 3 sides of a triangle. If we want to calculate the sine of an angle, we just divide the opposite by the hypotenuse. The next function of a right triangle, or the trigonometric function of a right triangle, is called the cosine, and cosine is abbreviated COS. And the cosine of an angle is the adjacent side, however long that is, divided by the hypotenuse. And we'll get to some examples down below. And then the third most important trigonometric function of a triangle is the tangent. And the tangent of an angle is the opposite side divided by the adjacent side. And that's where SohCohToa comes from. SohCohToa stands for, S stands for sine, and the sine of an angle is the opposite side divided by the hypotenuse. The cosine of an angle, C is cosine, means the adjacent side divided by the hypotenuse. And the tangent of an angle, that's what the T stands for, is the opposite side divided by the adjacent side. SohCohToa, these are just fractions. So the three main functions, and you should have worked with them before, are sine, cosine, and tangent. But there are also three other functions that aren't quite as important, but they're there, so we have to learn about them. They're called the cosecant, the secant, and the cotangent. First of all, the cosecant. The cosecant is the reciprocal of the sine, and the reciprocal means just take that fraction and flip them upside down. So the cosecant of an angle, instead of being opposite over hypotenuse, it's just hypotenuse divided by the opposite side. The next trigonometric function, the minor one, these are major ones and these are minor ones. The next minor one is the secant, and the secant is reciprocal of the cosine. The reciprocal of the cosine, instead of adjacent over hypotenuse, we just have the hypotenuse divided by the adjacent side, and that's the secant. And then the last one, this minor trigonometric function, is a cotangent, which is the reciprocal of the tangent, which is just the adjacent side divided by the opposite side. Now don't fall into the trap that a lot of people fall into. When we're talking about all six of these trigonometric functions, a lot of people think sine and secant are reciprocals just because they both begin with the letter S, but don't fall into that trap. Sine and cosecant are the reciprocals of each other. Cosine and secant are the reciprocals of each other. So don't match these two up. Like I said, don't match the cosine and the cosecant up as reciprocals of each other just because they both start with a C and then these two both start with an S. Don't fall into that trap. Cosecant can be expressed one other way. Because it's the reciprocal of the sine, we can also call this 1 divided by the sine. And because secant is the reciprocal of the cosine, we can also call this 1 divided by the cosine. And the cotangent, reciprocal of the tangent, we can call this 1 divided by the tangent. So these are just the reciprocals of the original major functions. Now what we're going to do is take three specific right triangles down here, and we're going to figure out all six sine, cosine, tangent, cosecant, secant, and cotangent of each one of these three examples. So when we look at this triangle right here, what they want us to talk about is this angle up here, because there's a little funny symbol in here. This symbol is a Greek letter. This Greek letter looks like an O with a line through it, kind of looks like Saturn. This Greek letter is called theta, T-H-E-T-A. We're going to be talking about a few Greek letters this year. You already know a few. You know what pi is. Pi is a Greek letter. Well, theta is another Greek letter. And in math, theta is used to represent an angle a lot. So we're going to be looking at this angle up here. And what we're given is two sides of a triangle. And if we know two sides of a right triangle, we can find the third side with the Pythagorean theorem, which goes a squared plus b squared equals c squared. C is the hypotenuse. We'll mark it as C. So this says 8 squared plus 6 squared equals c squared. 8, 6, and a c. 8 squared is 64. 6 squared is 36. 64 plus 36 is 100. So if c squared is equal to 100, then c is equal to the square root of 100, which is 10. So what we have now is all three sides of this triangle, 6, 8, 10. And now we can figure out what the sine of this angle is. Remember, the sine is the opposite side divided by the hypotenuse. Well, with this angle up here going directly across from this angle, this 8 is the opposite side, so I'll mark it with OPP for opposite. This C value is the hypotenuse, so I'll mark that with an HYP. And then the other side, the one that's right next to our angle, is the adjacent side, ADJ. So since the sine is the opposite over the hypotenuse, in this example it's 8 over 10. And you don't have to reduce that down if you don't want to, but it's usually a good idea, or it makes your math easier if you can reduce it down. So this sine is actually equal to 4/5. So the sine of this angle is 4/5. If we know the sine, we can get the cosecant really fast, because all we have to do is flip the sine upside down. Instead of 4/5, it's 5/4. The cosine is adjacent over hypotenuse. The adjacent side is 6, the hypotenuse is 10, and 6/10 reduces down to 3/5. And if we know the cosine, we can get the secant by just flipping the cosine upside down and calling it 5/3. The next one is the tangent. The tangent is the opposite side divided by the adjacent side. Opposite is 8, adjacent is 6, and 8/6 reduces down to 4/3. And if we know the tangent, we can flip the tangent upside down and get 3/4. Example number 2. We have 5 and a 10, and we don't know what c is. C is the hypotenuse. 5 squared plus 10 squared equals c squared, Pythagorean theorem. 5 squared is 25. 10 squared is 100. 125 is c squared. And now you have to take the square root, and the square root of 125, well, that can break down into 25 times 5. Take the square root of 25 and you get 5 square root of 5. That's equal to c. So here's c. 5 square root of 5. The sine, let's talk about this angle up here. Here's our theta. So across from theta, 10 is the opposite side, c is the hypotenuse, and 5 is the adjacent side, so mark those 3. Sine is opposite over adjacent, or opposite over hypotenuse, so we have 10 over 5 square root of 5. This 10 and this 5 reduce down to 2 over 1 square root of 5. And even though I think it's a waste of time, we're going to rationalize this denominator by multiplying the top and the bottom by the square root of 5. So we get, with a rational denominator, 2 square root of 5 all over 5. There's your sine. The cosecant is the upside down sign. Well, I'm going to take this 2 over the square root of 5 and flip them upside down and call them the square root of 5 over 2. Then I don't have to re-rationalize the denominator. The cosine is the adjacent over the hypotenuse. 5 over 5 square root of 5. This 5 reduces down with that 5 and becomes a 1. So we have 1 over the square root of 5. If you rationalize the denominator by multiplying the top and bottom by the square root of 5, you get the square root of 5 over 5. And since the cosine was 1 over the square root of 5, if you flip this upside down, you get the square root of 5 over 1. but you don't have to ever put over 1. It's just the square root of 5. Tangent is opposite over adjacent, 10 over 5, which is equal to 2. And the cotangent is the reciprocal of the tangent, so you have 5 over 10, which is a half. Example number 3. Here's your theta down here. Now we're given the opposite side because we're going straight across. There's the opposite side. We're given the hypotenuse. This is C, which is the hypotenuse. And now we do a squared plus b squared, which we don't know. So it goes 3 squared plus b squared equals 7 squared, because we already know the hypotenuse. So 3 squared is 9, 7 squared is 49, and if you subtract 9 from each side, you get b squared is equal to 40. b is the square root of 40. The square root of 40 breaks up into 4 times 10, so b is 2 square root of 10. And this is the adjacent side. So the sine is opposite over hypotenuse, 3 over 7. Cosecant is the flipped sine, 7 over 3. Cosine is adjacent over hypotenuse, which is 2 square root of 10 over 7. The secant is this flipped upside down, which is 7 over 2 square root of 10. But now we have to multiply top and bottom by the square root of 10. So the secant is 7 square root of 10 over 2 times the square root of 10 times the square root of 10 is 10. So 2 times 10 is 20. So it's 7 square root of 10 all over 20. Hopefully that's not too blurry for you. Let's see if I can focus this at all. I guess it was alright. Tangent, opposite over adjacent. Opposite is 3, adjacent is 2 square root of 10. Multiply top and bottom by the square root of 10 to rationalize the denominator, and you get 3 square root of 10 all over 2 times the square root of 10 times the square root of 10 is 10. 2 times 10 is 20. And then the cotangent is the flipped upside down, adjacent over opposite, which is 2 square root of 10 all over 3. And that's it for that section. Now this next set of 8 questions are pretty easy because it's just a button pushing exercise on your calculator. So we're going to use our calculator to evaluate these. So we're going to pull out our graphing calculator. Now the first thing you have to be aware of with a graphing calculator is when you press the mode button, you're going to look, and in the beginning we're going to be working with degrees only, so you're going to go down and you're going to set the mode to degrees, and then second quit out of that. The tangent of 10, you just press the tangent button, and the tangent of 10, that's the tangent of 10 degrees. Oops. And they want us to round this to 4 decimal places, so 0.1763 would be the tangent of 10. Number 8 says the cosecant of 40. Well, cosecant is the reciprocal of the sine, so in our calculator we're going to do 1 divided by the sine of 40. So here's our calculator, 1 divided by the sine of 40. That'll give us our cosecant, and it's 1.5557. Number 9 is the sine of 51. Sine 51, 0.7771. the cosine of 89, press the cos button, cos 89.017, well, this 5 rounds the 4 up, so this is 0.0175. 4 more to go, and then we'll call it a day. Secant is the reciprocal of the cosine, so this is 1 divided by the cosine of 29. So we do 1 divided by the cosine of 29. 1.143, oh, the 5 rounds the 3 up to a 4, so 1.1434 to 4 decimal places. The next one is the cosine of 3, cos of 3 degrees, 0.9986. The cotangent of 38 is 1 divided by the tangent of 38 degrees. 1 divided by the tangent of 38 degrees is 1.2799. And the last one of the day is the secant of 67. That is 1 divided by the cosine of 67. In our calculator, 1 divided by the cosine of 67 is 2.5593. And it looks like we've got a 22-minute video. I think that's long enough for today. We'll get some practice on this tomorrow in class. Have a great night.